यो भिडियोमा चाहिँ हामी फ्रैंक कन्डन प्रिन्सिपल डिस्कस गर्छौं। सामान्य जानकारी एक्जाममा कसरी लेख्ने त्यो चाहिँ सेकेन्ड सेमको सिलेबसमा छ फ्रैंक कन्डन प्रिन्सिपल भनेर र इम्पोर्टेन्ट पनि छ, धेरैचोटि एक्जाममा सोधेको पनि हो। सो इफ वी गो हियर है, यो ओके, सो दिस इज द फ्रैंक कन्डन प्रिन्सिपल। सो व्हाट डज इट स्टेट? फ्रैंक कन्डन प्रिन्सिपलले चाहिँ यसको प्रिन्सिपल यहाँ छ, कुनै पनि इलेक्ट्रोन जब फोटोन whenever a photon है, let me draw a diagram. So since the electron चाहिँ they always sits in a एउटा कुनै स्टेट, एउटा लेभल हुन्छ, त्यो लेभलमा त्यो बस्छ है। इट क्यान आइदर बी हियर, आइदर बी हियर or either be here. Okay, so जहिले पनि फोटोन whenever it strike the electron, then it get excited and it moves to a whole new level. Okay, so whole new level, and after a certain time it returns to a lower state or ground state depending upon the emission spectrum. So when the photon hits the electron, it gets absorb. Okay, so that is the absorption spectrum, and when the electron reach at certain level, then after releasing some spectrum that is called emission spectrum, then it falls to the ground level or lower energy state. Okay, so that is clear. So now what Franck Condon principle does is that it gives us the intensity of that spectrum. Okay, so during the absorption or the emission spectrum, not all the spectrum are of the same intensity. So what is the principle to calculate the intensity? That is the Franck Condon principle. So I think यो बुझ्नु भयो होला। फ्रैंक कन्डन प्रिन्सिपलले चाहिँ इलेक्ट्रोनलाई चाहिँ फोटोनले हिट गर्दाखेरि जब त्यो हायर एनर्जी स्टेटमा जान्छ र फेरि जम्प गरेर हैन त्यसपछि ड्रप भएर तल स्टेटमा आउँछ, त्यो इन्टेन्सिटी जुन हुन्छ एब्जर्प्सन र इमिसन स्पेक्ट्रमको, त्यसको इन्टेन्सिटी क्याल्कुलेट कसले, त्यसको बेसिक आइडिया, त्यसको प्रिन्सिपल के हो? फ्रैंक कन्डन प्रिन्सिपल हो। ओके, सो आई थिंक इट इज मोर क्लियर। ओके, सो यहाँ पनि भनेको छ है ओके, सो द बेसिक आइडिया बिहाइन्ड द फ्रैंक कन्डन प्रिन्सिपल इज द्याट हामीले क्याल्कुलेट गर्दाखेरि द इलेक्ट्रोन जम्प इन अ मलिक्युल। ओके, सो यहाँले के कुरा लेखेको छ भनेपछि इलेक्ट्रोन चाहिँ सिन्स इट इज यो चाहिँ बोन ओपन हाइमर एप्रोक्सिमेसनमा बेस्ड छ है, त्यसले के भन्छ भनेपछि द न्यूक्लियस इज कन्सिडर अ हेभियर देन इलेक्ट्रोन। सो व्हाट ह्यापन्स इज दैट इफ वी एज्युम दैट, then let's suppose the nuclear size is this and electron size is this. So during the transition, the motion of the nucleus is considered absolute zero or negligible. Okay, so nuclear मा कुनै मोसन हुँदैन, but the electron we take its position, it changes its position. Okay, so we cannot treat it as a rest mass electron, but for a nuclear mass we can treat it as in resting position. Okay, after the absorption and then after the emission. So between absorption we can treat nucleus as in a rest position because of its large size and heavy size, but electron they change the position. Okay, so this is given in here. किनभने because nuclei have nearly the nuclei are large in size, so nuclei will have nearly the same relative position and velocity as before the transition. Okay, so यो कुराहरु भयो। Now to calculate the transition after the photon hit the electron and then after the emission भनेपछि, so there are two states. Okay, so clearly, so this is case 1. Okay, so this is case 2. So at first electron यहाँ थियो, photon it hits the photon, then it goes to the higher energy state. So this is case 1, and after sitting there it emits the spectrum and then it falls to the lower energy state. So how we define the position of electron, or how we define the behavior of this electron. It is given by the Schrodinger. So we define every quantum particle by its wave function. So this is the wave function I before the electron jumps to the higher energy state, and this is after it gets emitted to the lower energy state. So these are the two wave function. This is initial wave function, this is final wave function. And now here, since we are considering here two objects, that is electron and the neutron, so the two wave functions, okay, so the total wave function will be electronic wave function and the nuclear wave function. So for initial state, the total wave function will be the initial state of electronic wave function and the initial state of the neutron wave function, nuclear wave function. And similarly for the final state, right, it will be the product of the final electronic wave function and the final nuclear wave function. Clear? So this is the initial state, this is the final state. Now what is the property of electron that we can define and we can calculate it to get the transition, the amplitude of the transition or the transition intensity? So that is given by the molecular dipole moment. Okay, so the molecular dipole moment is determined by charge and the location of electron, as well as charge and location of the nuclei. So we sum both the dipole moment. So this is this. Now what will be the probability of the amplitude for the transition? So it is clearly given by this. Okay, so now this is all clear. So let me just zoom in. So we can, this is Bryan-Kett notation. If we write into the integral notation, that can be written as this. Now mu is the sum of both electron and the nuclear wave function, as we know this. So now this is the final electron wave function and nuclear wave function. This is initial. Okay, so if we go here, now what I have done is I have individually I have मैले चाहिँ यो bracket open गरेको छु है. So there is nothing new in here. So this is this mu e and this is mu n. Now I have again separated this like electron electron, neutron neutron. So neutron neutron, electron electron, electron electron, neutron neutron. So this is the very important. We know the property of this. Okay, so we have the property in the quantum physics. So this is conjugate of this wave function ij is equal to 0 if I is equal to j is not. So if I is not equal to j, then this will be 0. Now since the electron, let me say this is ground state, now it moves to the upper state. Let me say that is n is equal to 2. So initial state and the final state are not in same order. So I is not equal to j, so this will be 0 for electron. And where it is, so this will be 0. Okay, so this will be, this entire term will be 0 because electron jumps from one state to another. But in case of nucleus, we did not consider it to be moving, we consider it to be in a rest position, though that will be not equal to 0. Okay, so this is the property it is given. So now we define a new term, that is SO. Okay, so that is the intensity factor. So we define this as intensity factor. Okay, so यहाँ हेरौँ त, we define it with S. Okay, so this term is सबै 0 भइहाल्यो. Okay, and now this term चाहिँ हामीले के define गर्यौं, we define it as a intensity factor. Okay, because it has a dipole moment. Okay, electron dipole moment. Now यहाँ पनि भनेको छ this term will be equal to 0. So this is this S and that is that. Okay, so since it is 0, so 0 multiplied by something is will be 0, so only remaining term will be this. So this is this. Now so S is called the Franck Condon factor. What it represents? It represents the overlap between the vibrational wave function in the initial state and the final state. यो भनेको के हो? Okay, so what it does is that now we if we see here a graph, so this is after the transition and this is before the transition. These are the vibrational wave function. Okay, so these are the vibrational wave function. Okay, so vibrational state. Now कुन दुईटा let me say the state मा चाहिँ maximum transition probability हुन्छ, जसको चाहिँ यो ओभरल्याप जुन छ नि, यो ओभरल्याप जसले चाहिँ बेसी ओभरल्याप गर्छ त्यहाँ चाहिँ यसको ट्रान्जिसन हुन्छ. ओके, सो that area will have the highest intensity. हामीले के भनेको थियौं, फ्रैंक कन्डन प्रिन्सिपलले it helps us to determine the intensity of the electronic transition. So how it defined, हामीले हिसाब गर्यौं, we found the factor S. Okay, so if factor S has a maximum value, त्यो भ्यालु कसरी आउँछ, it has to overlap between the maximum overlap हुनु पर्यो. So यहाँ चाहिँ जुम इन भ्यूमा छ. So consider this as the initial vibrational wave function. Okay, so if we go above this is the after the electron gets some, यो चाहिँ higher energy state भयो. So यो सँग के छ, यो सँग overlap छ छैन, यो सँग अलिकति यो in compared to this is maximum overlap, तर यो सँग के छ, perfectly match छ. So the electron will likely to make jump from here to here, so it will have the highest maximum intensity. अरु पनि लाइनहरु हुन्छ, नहुने होइन. ओके, so but the maximum intensity will given by this. So this state and this state will have the highest value of S. Okay, which is Franck Condon factor. So S ले के measure गर्छ, it measures the overlap between the two vibrational wave function. Okay, so it is given in here. If the overlap of the wave function state is not 0, if S is not equal to 0, that is यो भएन भने के हुन्छ, the spectral line of the corresponding will be observed. Okay, so that is okay. ल यसमा जान्नु पर्ने कुरा भनेको चाहिँ यो सबै तपाईले पढ्नु होला, आफ्टर बुक विल बी पब्लिश. ओके, सो चाँडै नै पब्लिश हुन्छ. यसमा इम्पोर्टेन्ट नोट भनेको चाहिँ सेपरेसन डिस्टेन्स रिमाइन कन्स्टेन्ट ड्युरिङ द ट्रान्जिसन. सो के हुन्छ, यो इलेक्ट्रोन चाहिँ सिधा जान्छ है, लाइक हुन्छ नि, यो इलेक्ट्रोन चाहिँ यसरी डायगोनली मुभ गर्दैन. ओके, सो इट डज नट मुभ डायगोनली. एन्ड देन जब यो ट्रान्जिसन भइसक्छ त्यसपछि चाहिँ यो जुन लेटर मुभ्स टु अ न्यू इक्विलिब्रियम पोजिसन. ओके, सो यो जुन यो डिस्टेन्स जुन छ नि, यो डिस्टेन्स कन्स्ट्यान्ट नै रहन्छ, बट आफ्टर इट द इलेक्ट्रोन मेक्स अ जम्प हियर, त्यसपछि चाहिँ न्युक्लियरले आफैलाई चाहिँ रिपोजिसन गर्छ टु अ न्यू इक्विलिब्रियम स्टेट. Okay, so त्यो जान्नुपर्ने कुरा हुन्छ. An electron transition can go to any number of different vibration level in the excited depending on the energy. So that is obvious. So anyhow, यति कुरा एक्जाममा लेख्नु भयो भने you will get a full marks. I hope so. So this is Franck Condon principle. So there are a lot of formula. यो syllabus नै कभर गरेको छु मैले, हेर्न सक्नुहुन्छ. Everything in there. Okay, so Royal Physicists भन्ने ग्रुपमा यदि एड हुनु भएको छैन भने प्लिज एड हुन. आफ्टर द बुक इज पब्लिस्ड आई विल इमिडिएटली अपलोड द टाइम, द प्राइस एन्ड द लोकेसन वेयर यू क्यान बाई द बुक. ओके, सो आई होप यू गेट द कन्सेप्ट. के क्वेसनहरु छ भने कमेन्टमा लेखिदिनु होला, एन्ड आई विल गेट ब्याक टु यु गाइज विथ अनदर थ्योरम इन सम अदर डे. ओके, सो थ्याङ्क यू सो मच फर वाचिङ. Thank you so much.